Thanks for inviting me to CalBEM. I'm Joshua New from Oak Ridge National Laboratory, and I'm here to present Model America, a model of every U.S. building. There are 125 million residential and commercial buildings in the U.S. that account for $400 billion per year in energy bills. That's 40% of the nation's primary energy, 39% of emissions, 73% of electricity, and 80% of peak demand. I work most closely with DOE's Building Technologies Office using modeling to assess the most cost-effective technologies for reducing building energy demand and emissions. Of those 125 million buildings, we build 1% new per year. For the rest, there is over $20 billion a year in market activity across cities, utilities, and energy service companies that improve approximately 0.3% of buildings per year. There's a significant investment opportunity with a largely unserved market of small commercial and residential buildings. What is needed to scalably answer relevant business questions in terms of buildings, technologies, and cost effectiveness? Whether you're a city or community looking to reduce greenhouse gas emissions, a utility looking at equitable tariff structures, building technology manufacturer looking for sales leads, energy service company looking for preliminary audit data, or an innovator in search of disruptive business models, how could taxpayer resources be allocated to create a rising tide that lifts all boats? Well, we came up with the 5-year vision of creating a building energy model for every U.S. building. Let me start by saying that we don't have good data about individual buildings and formats that are consistent at nation scale, so gathering data to create an initial benchmark is challenging. If a building energy model can be created, there are automated software tool chains for trying different technologies or packages to determine optimal retrofits that reduce energy use. Then for everything else, renewables such as PV siding and generation can help offset. If you'll forgive the simplification, benchmark, reduce, and offset is my 3-step BRO model to a sustainable built environment. How do you create a model of every U.S. building? I'm going to attempt to summarize our 7-step technical process in one slide. Number 1, sensitivity analysis. Just like life, don't major in minors, what matters and how much. We modified up to 4,700 parameters to quantify the impact in terms of kilowatt hours and kilowatts. Number 2, to do that, we had to use 3 of the world's #1 fastest supercomputers. Number 3, we created a comparison matrix of over 40 data sources that tell us the spatio-temporal resolution, costs, licensing limitations, API rate call limits, and other details. Number 4, we established partnerships with companies that are in the business of creating and processing this data. Number 5, advances in artificial intelligence were made to process the data at scale. Number 6, we're not Big Brother, so we stuck with the DOE prototype details as an intelligent best guess as to the internal building characteristics. And number 7, we plan to make these models freely and openly available for any simulation-informed use case. When I speak of creating a model or digital twin of each building, we're primarily using DOE's flagship whole building simulation engine Energy Plus and middleware Open Studio, which DOE has invested over $100 million in since 1995 and is open source on GitHub. We've been able to scale this built-for-desktop software to run on the world's fastest supercomputers to the tune of over 1 million building simulations in 1 hour. We first tested this in partnership with the Electric Power Board of Chattanooga, Tennessee, who provided 15-minute electricity use from each of over 178,000 buildings that we used to quantify the error between each model and measured data. We used building-specific models to quantify energy, demand, emissions, and cost savings at each premise, and then aggregated up to critically loaded feeders, substations, and the entire utility service area. These results are publicly available at bit.ly/virtual_EPB, where clicking on an individual building gives the technology-specific and retrofit package absolute and relative savings for kilowatt hours, kilowatts, and dollars. I was inspired by a quote misattributed to Abraham Lincoln that said, "If I had 5 minutes to chop down a tree, I'd spend 4 minutes sharpening my axe." For me, the axe is the software pipeline. What we did for EPB, we did in a way that we could apply to the entire nation. We achieved our goal of creating a model for every U.S. building, simulated each building's 8760 energy profile, and made the Energy Plus and Open Studio models freely available online at bit.ly/modelamerica. This includes 10,781,502 buildings in California that we currently detect from space. Most organizations are either not interested or not capable of simulating and analyzing every building, so dynamic archetyping software has been created which can automatically take a shapefile for any region of interest and provide models with floor space multipliers to simplify the analysis process. The software we created for this we refer to as Automatic Building Energy Modeling, or AutoBEM. You can find building-specific metadata and visualizations, as well as related publications at bit.ly/AutoBEM. Thank you for your time, and I wish you an informative CalBEM 2021.